Hello everyone, after the second video in which we looked in details into the method to find the nth term for a quadratic sequence, we are now going to look at a few alternatives to find this nth term. So this video is more targeted for students who really feel comfortable with the subject and want to get some wider views on the topic. So let's start by looking at the general term of a quadratic sequence. Tn is an squared plus bn plus c. We've seen in the first video that the difference in between two consecutive terms is a linear sequence with general term 2an plus a plus b. This means, for example, that t2 minus t1 is equal to 2a times 1, which is 2a, plus a plus b, which is 3a plus b. This here is an important result that we'll keep in mind for later. Also, substituting n for 1 or 0 in this expression shows that term number 1 in a quadratic sequence is the sum of the three coefficients a, b, and c, and that term number 0, that is never to be shown, but that would be the term before term number 1, would be c. With these four results here, we are now ready to investigate alternative ways to find the nth term for a quadratic sequence. To start, the first step is always the same, and that is to get the difference in between consecutive terms here. Here are these differences. We can check by looking at the second differences here, which are 6, that this is a linear sequence. So let's find the general term for this green sequence. Because it's going up in 6, it's going to be of the kind 6n plus term number 0. So if you go backward here, you're going to subtract 6, and term number 0 is going to be a 1. This means that we can now match this formula here with what we found for the difference here in between two consecutive terms. This 2a here is going to be the 6, meaning that a is going to be 3, and the 1 right here is going to be the a plus b, so this means that 3 plus b is going to be 1, meaning that b is going to be minus 2. Here we can notice that we could have worked out this b here by using the second formula here instead. If you look at the difference between term number 2 and term number 1, it's this one, so that's 7. So 3 times a, after we found a, is 3 times 3, it's a 9. And to get the 7, you need to add a b, which is a minus 2. Now that we have a and b, we can use the fact that t1 is the sum of these three coefficients. So a plus b is going to be 1. So if you want to get to term number 1, which is minus 5, you need to take c as minus 6. Again here, we could have used another way to find the c. We've seen that term number 0 in the sequence should be a c, so we need to get term number 0 by continuing the sequence on the left. We've seen that this difference here should be a 1 to continue the sequence right there. So this means that we've started from minus 6. And you see that this minus 6 is the c that we found. So it's quite interesting to see that regardless to the way you look at it, and regardless of the formulas here that you use, we obviously always find the same coefficients for the nth term of the quadratic sequence. In this case, you can write that tn is equal to 3n squared minus 2n minus 6. So if you feel comfortable with that, you can pick any of these methods to find these coefficients. Well, I hope this little video helped you broaden your views on the topic, and see you next time.